Good morning. How are you today? Good. I know you have a little migraine and not feeling good. Thank you so much for making my class today. I appreciate you. Whenever you feel not comfortable, you may leave. That's okay. Yeah, you may leave. So today we are going to talk about chapter 3. After today's chapter, you will take exam 1. Exam 1 is online exam. So if I finish today everything, you can take your exam online tomorrow, anytime. Anytime you can choose and go to Blackboard and take exam. Yeah. But if we cannot finish this chapter, maybe I need to extend maybe next week. Yeah. Whenever we finish chapter 3, which is like a Tuesday, and probably we will take exam maybe Wednesday. Okay. But I think I can finish this chapter because this chapter is like a little extension of brain and behavior. We are focusing on our sensory receptor, sensation and perception. So the big title is sensation and perception. So we will go one by one. Okay, maybe I'm gonna put that name card right here. Okay, so here. So underline, sensation means ability to the sensory organs to pick up the energy in environment around the body and try to send those signals to your brain. So when you touch and when you smell, when you hear, when you see, those environmental information, it should be sent to your brain. More like a transitional kind of information to your brain. So those are all the sensation. Those outside energy you pick up, like you're singing, you're hearing, and you're tasting, and send those signals to your brain. So brain recognize, oh, that's too sour, that's too bitter, that's too sweet. Yeah, you can kind of say. So perception can be interpretation of all different kind of your sensation. Some of you may, I think Daniel shared with us, like you feel like a more bitter taste than other people. Yeah, bitterness. So in that sense, interpretation. The perception wise, maybe some bitter tastes. For somebody else, it can be less bitter and more bitter. And whenever you go outside, you see sky. Have you ever seen sky today? It's pretty much cloudy and not that, like pretty sky, but usually when you see like a sky in the fall season, you see lots of clouds. Yeah, lots of clouds. I love looking at clouds personally. And whenever I see clouds, I'm thinking about cotton candy because I feel like it looks like a little cotton candy. I love to eat cotton candy. So it looks like cotton candy to me, those clouds. But when you see maybe clouds, like a white clouds, what do you feel like? What comes into your mind, Daniel? Maybe when you see like a clouds, it looks like.
I mean, cotton candy's close. Cotton balls.
Cotton ball, yeah.
Sometimes they shape into something that's, I don't know.
Yes, yeah, yes, very good. So even though we see the same object, we may interpret differently. I know Daniel maybe need to leave early home very early usually, yeah, like 7 and try to drive, come here. So maybe when you see one day, maybe when you feel really tired, maybe go back home. When you see like a cloud, it looks like a little cover. Like a very cozy cover, so maybe I kind of sleep in. You may think in that way too. Those are perception. So sensation is you do see, oh, you do hear, yeah. Those are like a sound, you do hear, yeah. And then we are gonna test like a perfume soon. Like you do smell, yeah, and how we can kind of send those signals to our brain. So those are sensation. But perception is depending on us. We may interpret differently. So sensation and perception, that's this chapter. Okay, so in this chapter, we will talk about absolute threshold, different threshold, sensory adaptation, and perceptual constancy. So let's go one by one. So absolute threshold, underline, it will be on your exam. It's a minimal level of stimulus necessary for a person to detect its presence at least 0.5% right. So maybe let's be quiet. Can you hear the other room? I think the instructor is talking, so let's figure it out if we can notice or not. I will be quiet too. Do you hear anything?
I heard somebody do
Yes.
it now.
Yeah.
About that
Yes, yes,
installation
yes.
and
Yeah, that's the exactly absolute threshold. If there's like a certain sound, like a tick-tock sound, we try to be quiet. Maybe half of us, which is between maybe you and me here, so maybe one of us recognize, yeah, I heard somebody else like a tick-tock sound, or maybe some voice, yeah. So those are least kind of stimulus, I mean the minimum level of stimulus you can recognize if there is a tick-tock sound or not, if there is some smell or not. Those are absolute threshold. So here, based on the research, there's a vision, touch, hearing, and smell and taste. We are going to do a little experiment today. Vision-wise, the candle, maybe 30 miles away. Do you have a good vision, Daniel?
Good vision?
Yeah. Like a 2020? You can kind of read it pretty much. You was 2020?
I don't know if I still am. But
Okay. I do not have a good vision. My eyesight is getting worse. So I'm wearing contact lenses at home. I mean, here and at home, I'm wearing glasses. So, my vision is not clear. So if I take off my contact lenses and 30 miles away and try to see like a one flame, those are the candle flame, I cannot recognize. But I guess 2020 vision, just like Daniel, who has a good vision, maybe 30 miles away, possibility is like a 50% chance. Yeah, I see candle frame right there. Those are minimal amount of energy we can recognize. Yeah, there's a candle flame or not. And hearing is like a 20 feet away. There's a little tick-tock sound. Maybe some watch does have those tick-tock sound. So can you recognize those sound? Daniel, do you feel like I'm pretty good like hearing? Do you have a good hearing ability?
Not so much anymore.
Anymore? Yeah.
Too many loud stuff going around.
Yeah.
In the army.
Oh, yeah, sure. Because, we will talk about hearing. Once you lose hearing sound, it will not come back.
Yeah,
That's really... That's really sad, yeah. Because when you're thinking about your tongue, when maybe you really like some hot soup, so you just kind of, you're so hungry and try to eat those hot soup so quickly, you just burn your tongue and you feel like, you cannot taste, you feel like a little weird taste for a while. But once you pass like 1 week and 10 days, you can kind of recover. Maybe get back to your normal taste bud and you can taste the same. But hearing is different. Once you lose those, the hair cell inside of your ear, it's gone. So you cannot hear just like before. So can you thinking of a band player, like a percussion player? They are listening all the time, all the beats and practice crazy, right? All the time. So they need to use earplug, whenever they play and maybe some exercise, at least like a playing exercise. But if they don't, they may lose hearing so quickly. So I realized if you used to play band during junior high and high school, they usually do not have a good hearing. Yeah, they kind of admit because they always hear and, kind of marching together, and somehow they lost a little bit of their hearing ability because that's why maybe your mom, usually mom told their the children, do not listen to music too loudly. Maybe ear plug, maybe that's not good device.
Earphones are worse for you than if you were just in a loud room.
Yeah.
The same amount of loudness and earphones will damage more hair follicles than just listening and how close the vibrations are to your ears.
Yeah. So there's a reason why our parents and maybe grandparents worry about us. So recent kids, we are wearing always AirPod. Yeah. So we will talk a little bit about those hearing session and smell and taste. So taste-wise. Are you sensitive to the taste or maybe not really? Only bitter taste?
Sensitive to some taste, but not really.
Okay, so taste-wise, if there's not 1 gallon, 2 gallons of water, and if you put like 1 teaspoon of sugar, kind of mix it, do you feel like, can you recognize, this is not a regular water, this is a sugar water? Can you tell? Okay, even like 2 gallons of water and 1 teaspoon of sugar, you feel like you can kind of recognize it?
Maybe 1 gallon. I don't know about 2 gallons.
Okay, okay, good. So for me, it can be hard because I just like all the food and taste. Sometimes for me, it's not that big difference. Maybe that's why I'm not that picky because some of them, oh, if you go that restaurant, maybe salsa is sour. Maybe you can kind of recognize the big differences. But for me, if it's salsa and chip, oh, it's similar. Whenever you go, maybe order the salsa and chip. So for me, it's really hard to, maybe it would be hard to recognize taste 1 teaspoon of sugar into like 2 gallons of water. So let's do smell today. So based on those study, if you make a 1 puff in like a 3-bedroom apartment, you should recognize. We are talking about absolute threshold. Like a chance will be 50%, you can recognize, there's a certain smell going on. So I know maybe if I'm gonna do like only 1 puff, and then you should go away. If you smell maybe certain perfume, raise your hand, okay? Yeah, I mean, it's supposed to be, but I realize we are not that sensitive. So maybe we can do 1 more. Maybe backside, I'm gonna make 1 more puff. And Daniel, if you smell it, raise your hand, okay? Do you smell it? No? One more. Very near you.
And I'm pretty sensitive to smell. If I walk into a Bath and Body Works, I'll get a headache.
Oh, okay. So now do you smell anything?
Not yet.
Not yet, okay. When you comes, maybe you can raise your hand.
We don't have a whole lot of circulation in here yet.
Okay.
It's moving
Okay.
around much.
Yeah. Maybe I need to. Okay, 1 more. Right there, if you don't mind. Supposed to be.
Okay, I smell it now.
You smell. Okay. So, I mean, this.
Definitely smell it now.
Yeah.
It's kicking in now.
Yes, yes. How does it smell like?
I can smell the little bit of alcohol that's in it,
Okay.
and I don't know what the smell is supposed to smell like. But
Like a
I definitely
musky?
smell a little bit of the alcohol in it.
Okay, okay, good, good. Honestly, I do not like this perfume. So, whenever I do like this chapter 3, I bring this and then try to like lessen the smell. And, raise your hand if you can smell. Usually 1 puff doesn't work. 3 to, even like 4 to 5. Yeah, it will work in that way. So I did like 3 times and I guess that's the norm for in this class. Yeah, usually I need to do at least 3 pump of those, like a perfume, and then students can recognize those smell. But those are underlying absolute threshold. So we kind of having fun, like an absolute threshold. Like a little bee right here. Do you like bees or
I
you like
bees
bees?
fine, yeah.
I'm afraid of bees. And bee may
they're
sting
not
you.
Really that scary. They
They're
don't
not
really
scary?
Mess with you unless you mess with them, and they're really good for the planet.
Okay, okay.
But I forget what I was saying. Never mind.
Okay, okay. Yeah, so maybe the touching wise, if a bee is 1 centimeter away and kind of like a flying near you, you may notice it, like there's a bee around me. Yeah, so those are just underline absolute threshold, focusing on the definition for your exam. So if you feel like I don't understand this concept, it will not on your exam because exam will be very based on the basic definition and what we've been talking about. Okay?
They couldn't call it minimum threshold.
Uh.
That would be so much easier.
Yeah, it's all multiple choice, so try to choose the best one.
No, that's
Okay?
That's not very hard to remember. I'm just saying.
Yeah.
Minimum threshold would have made a lot more sense.
Okay, okay, yeah, because minimum amount of energy you can notice, right? Yeah, but remember those are absolute threshold. Okay, so those are extra information I've been explained. So let's go. Difference threshold. Different threshold. There's a 2 slightly like a smallest change, one stimulus and the other, and person can notice it like a 0.5% right, like a 50%. Do you like a Coke? Or at least can you differentiate maybe Coca-Cola and Pepsi?
100%.
100%. What's the difference?
They just make it with different ingredients. One has a very distinct flavor compared to the other one.
Okay, which one do you prefer?
I don't like either of them.
Okay.
So, neither.
Yeah, sure. So like maybe we can blindfold you, and if in front of you two drinks, like one is Pepsi and
I'd
Coke,
100%
you feel like
say
you
which
can.
one's Pepsi, yeah.
Okay.
They're gross. Coke and Pepsi are both gross.
Uh-huh. Okay, but you can definitely tell, oh, this is Pepsi and this is Coke,
Okay.
right? Okay, good. How about maybe Coke, regular Coke versus Diet Coke? Can you feel like maybe differentiate those?
I don't know. I don't think I've ever even tried Diet Coke, so.
Okay, okay, yeah. Okay, thank you. So, those are more like a difference threshold. Absolute threshold is if there is that little, like at least you can recognize if there's the sound or not. That's the absolute threshold. Different threshold is there any like a smallest amount you can differentiate? One and the other, those are different. It's a different Coke. Those are different threshold. Sensory adaptation, I'm kind of checking like a definition because this chapter is more relaxing chapter, so we need to enjoy and visual illusion and all kind of different concept here. So visual sensory adaptation is when you just like a smell, yeah, here. So perfume, I kind of gave you, the spray here, 3 pumps of perfume. So probably I do smell too. I do smell, yeah, a little bit of perfume smell, but maybe we will used to be, you will use to very quickly because smell is really used to kind of, maybe we can kind of, use very quickly. Sometimes even sound. Maybe you are surrounded with very loud bands, maybe in the concert. At the beginning, you feel like maybe my ears hurt. Maybe I cannot hear you well, but once you kind of, get together with those people and shouting together, maybe you do not feel not that, loud anymore because you just kind of belong to them and, surrounded those environment. Those are sensory adaptation. Smells, usually you can kind of mingle very quickly. Let's just say your mom is cooking for you, goulash. That's your favorite food, yeah, goulash. And when you kind of enter the home, you feel like, oh, it's a really good smell of goulash, right? But once you are there inside of your house, and then maybe your mom is still cooking, maybe you do not notice not much clearly the goulash smell, right? So those are more like a sensory adaptation. We do see, we do hear, and we just kind of, taste certain maybe food. It's already used to it, and maybe not that strong taste anymore, not that strong, smell anymore. Those are sensory adaptation. So looking at here, this is a computer, yeah, laptop. If you're looking at the first one, can you recognize that one as a laptop? Yeah, kind of like a opened laptop, yeah. And when you're looking at the second one, this is a little closed, maybe 45-degree kind of closed. And the third one is like a 30-degree kind of opened, yeah, those laptop. And the last one will be completely shut, yeah, those are laptop. So as an adult, we can recognize those are one laptop, yeah. So showing the first one up to like a bottom of those folder, you may notice that as a same laptop. Do you? Yeah. But an interesting thing is even like a 3-month-old baby, they're gonna recognize this as a one same object. They may do not know this is a laptop, but they recognize this one as a solid one object. Those are perceptual constancy. You may feel like, yeah, of course, that's a one object, but imagine when you see bottom one, versus when you see the second one, 30-degree angle open, and like a 90-degree open, you may maybe feel it's a different object. But human being, we are born with those ability, which is perceptual constancy. So when you see certain object, it's the same object we can recognize, even though it's a different angle and open and closed. So that's one of the amazing abilities starting from early age. Okay. So whenever we figured it out, what is those? We try to touch and taste and maybe maybe kind of in exercise with our hands. Those are more like a bottom-up processing. Sensation, and maybe you can kind of sense, so this is like a round shape of a ball, and maybe it does like a little sound, and try to maybe learn this one as, those are like a little shaker. Yeah, so starting from the bottom to kind of touching and maybe tasting and hearing, and then recognize a certain object, those are like a bottom-up processing. So top-down processing is you already have experience. So when you kind of see certain number or certain object, you already knew it because previously you already learned that concept. So let's do this one. So this chapter is more like a relaxing chapter. We kind of enjoy and do this. So Daniel, if you're looking at here, in the middle number, what is the number in the middle? Can you tell me?
It could be 2 or it could be 11.
Okay, very good, very good. So when you say it can be 2, how does it work in that way?
Well, I mean, just looking at it looks like maybe Roman numerals 1, 2,
Uh-huh.
3, but you also it could be 11 or 111. So
Okay.
a little more context.
Okay, very good, very good. So those are more like a top-down processing and perceptual set because we already learned all the Arabic numbers starting from very early age 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you're kind of looking at this chart, of course when you kind of read across 10, 11, 12. That's the right answer. But no, by the way, I learned Roman number 2. Those are 1, 2, 3. So the middle part can be depending on the context. You did a really good job. Depending on the context, it can be number 2 or number 11. Yeah, those are more like a top-down because we already knew the number system and then recognize if it is 2 or 11. Right? Yeah, those are perceptual set and also top-down approach. So we are gonna watch one video clip. You may already knew this concept in attentional blindness. I mean, as a human being, we are really focusing on maybe attentive to certain things, but sometimes we are not. So let's recognize, and we are gonna watch this monkey business. Okay, here. Okay. So, okay, let's pay attention to those because you need to count how many balls they are passing each other. Okay.
The monkey business illusion. Count how many times the players wearing white pass the ball.
Okay, just a second. Oh, okay.
The monkey business
I'm
illusion.
sorry. Just a second. I put right here. Like this. Okay, sorry. Okay, sorry, but let's hear one more time.
The monkey business illusion. Count how many times the players wearing white pass the ball.
Ready? Yeah, passing the ball. Oh, no.
I said 13. I already lost.
Oh, you said 13? Okay. So actually the actual count was, it will say here.
The correct answer is 16 passes.
Okay, so correct answer was 16 passes. So when you're really focusing on those counting, have you ever seen gorilla was there?
Yeah.
Yeah, kind of monkey, yeah, was there. Have you noticed like a curtain has changed? The color of a curtain was changed? No? So let's figure it out, okay?
Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion.
Okay, so we will talk about how we are very sometimes attentive only for one thing and then missing several other scenes. But we feel like I'm sure I've seen that one, but actually you missed several couple of things. Yeah, so we will talk about those illusions from now on about like a vision session. So it will be interesting. So let's go. Okay. So the major part is, first we will talk about vision. And we'll talk about vision and hearing and taste and our skin sense and balance, yeah, in this whole chapter. So vision is thinking about how many do we have those in the eyes. We have 2 eyes, and some of us, including me, I'm having contact lenses and glasses. So I feel like I have 4 eyes sometimes, yeah. But eyes. So today is the day we will learn about anatomy of eye. So eye part is right there. So here, if you're looking at this eye, imagine in front of you, you have some, big ball, like maybe soccer ball. Imagine those are soccer ball. So we do see like a person's eye only front, but back side, it's like a round shape, like a little ball. So imagine those are all the eyeball. So if light comes through your eye, underline, first, like a little transparent covering of your eye part, those are cornea. So cornea. So usually I'm wearing my contact lenses and try to make my lens and put my lens on that cornea. Yeah, those are cornea. So thin, transparent covering of the eye, which is first light will go through the cornea. And if you're looking at here, pupil. So when you are in sympathetic nervous system and parasympathetic nervous system, if you remember. So when you are in sympathetic nervous system, your eye will be widened. Those pupil will be widened, right? And then sometimes it can be shrinking too, right? So widen your pupil. So those are little hole. So imagine little hole and it's like a big soccer ball. And then all the light go through the cornea first, on the line, cornea first, and through those holes, we call it those are pupil. Pupil, yeah. And then sending those signal to the back side of your eyeball, retina, right here, yeah. So iris, on the line, iris means like a colored your eye part, like a little muscle, kind of hold, adjusting those pupil. So here, cornea is, those are pupil, is a little hole is right there. So right next beside those pupil, iris, those are muscle part, kind of adjusting your light, receiving, maybe less receiving, pupil dilating, or maybe constrict. Those are adjustment. So what color is your eye, Daniel? What color?
Blue.
Okay, blue.
Gray.
Okay, yeah, okay.
They change.
It changed, right?
Yes, so
Yes, that's why I kind of noticed it. So when do you feel like you become blue and when become like gray?
I don't know. It all depends on
Okay.
how the day is. If it's a darker day or
Oh, I I
Might
see.
also deal with my how I feel.
Uh-huh.
'Cause sometimes they're bright blue, sometimes they're dark gray, and sometimes they're like a greenish gray.
Okay, okay. Yeah, that's really interesting to me. I mean, my eye color is brown, and I thought it's just brown all the time. But one of my best friends, her eye color is like a green, but I feel like just like you told me, in the nighttime, I feel like a more gray, and sometimes more like a bright, like a more like a bluish green. So I feel like her kind of eye color has been changed. Yeah, just like you mentioned. Yeah. So on the line. So when we say, oh, you have a brown eye, you have a green eye, you have a hazel eye, we are talking about iris. Yeah, not the pupil. The pupil is a hole. Yeah, that's the hole. Even like a soccer ball, and then hole. The light go through. First area is cornea, and going through those pupil, but surround those pupil area iris. Yeah, it's all different kind of color and make you unique. Yeah, maybe blue eyes and green eyes and brown eyes. So far so good, right? And after that, there's like a lens. So lens, if you give me like an index finger and try to kind of see, can you maybe go further and closer and looking at your finger, you may feel like a little thinness of your lens and kind of thickness of your lens, kind of adjusting your lens, like a little pressure when you kind of get closer, and then maybe further. So lenses, those are elastic kind of when you are young, more, but when you get older, it's less elastic. But like thinning your lens and thickening your lens, because you're kind of looking at your eye, looking at the index finger further and closer. So those are lens part. And backside, those are retina. It does have a photoreceptor. So photoreceptor, so we can recognize some, color vision versus like only black and white, yeah, red and cons. So I will go to the next slide so we can kind of keep talking. So lens, underline, visual accommodation. So when you're kind of thinking about thickness, thinness, because further you may feel like less pressure, and then going closer, you feel like a little thickness and little pressure. So thinningness and thickness, those are visual accommodation. Those are lens. Right behind, yeah, those iris part, lens is right there. So sometimes I need to wear glasses and I need to wear contact lenses because the shape of lens make you cannot see well the further one or the closer one. So cataract, have you ever heard about like a cataract? Maybe your grandma and grandpa maybe have some cataract and cataract surgery. Yeah, those are cloudiness of, like on your eyesight. Yeah, so those are lens. Yeah, so lens maybe having some little cloudiness on that lens. Used to be, we just kind of remove those cloudiness and then that's the surgery. But recently we do not remove, we just change the whole lens. So you just kind of change the whole lens and put the new lens right there. That's the surgery of cataract. So after that, those like a cloudiness will be gone and you will see more clearly. So those are lens. Retina is rear part. We are talking about one big soccer ball, right? And backside. We see only like a front here, but backside, not the whole like a head, but backside of your eyeball right here, retina, that's the visual simulation part. Yeah, so we do have two here, rod and cons. So retina contains two kinds of sensory receptor cells, rods and cons. So retina, backside of your eyeball, you may notice those dark. The rod is activating like when you are in dark area, so you can see some object more clearly. And cons, it's relating with your color vision, so you can detect color. So on the line, maybe you may remember in that way. We do have two photoreceptor, rods, and cons. And cons are relating with your color vision, So it's easy, like a color vision. So imagine like a newborn baby. They are not having good vision when you're just born. For like a first month or baby, they do not recognize color. So maybe that's why when you go to bookstore, this is for the new infant. Only black and white some books, yeah, for them. Because they can recognize black and white, but they don't have a color vision yet. So it will be developing starting from the second month of old. So until that, there's no cons for the newborn baby. So starting from second month, it's more clear, like fourth month and 6 months. Yeah, maybe when the baby become 1 year old, fully recognize all different color and also black and white. Yeah, so it's more like recognizable later on. So remember, rod and cones, those are two photoreceptors. So whenever you do see, oh, this is like a little golden color and yellow, and this is like a red. Yeah, we can recognize it so easily because we do have a cones and rods, right? But rods, we are working on more like a darker area, detect usually more like a black and white, yeah, more simple. And cones detect color. But color vision will be appear a little later. So newborn baby, they don't have a con, but they will develop more starting from the second month of their life. So you feel like this is kind of interesting information, like a vision, yeah? Okay, let's do blind spot demonstration. So Daniel, if you, okay, it's okay. Maybe we can kind of do here. Yeah, maybe I will use this one as a paper. I'm gonna use that. Let's make similar, yeah. Okay. And then I will make a blind spot test strip for you. Okay. Okay. Then you're right here. Okay. So when you're looking at here, we do see R and L. First, we can kind of cover your left eye. Can you cover your left eye? Yeah, left eye. Very good. And now you have your right eye is open. Try to looking at the R. There's a certain moment you can kind of back and forth moving your paper. There's a moment you do not see L at all. For me here, so focusing on only R, looking at only R, and there's a certain moment you do not see L. Those are your blind spot. Can you find it? Yeah. So more like this and this, and here, when you kind of cover your left eyes, looking at only R sign with your right eye, focusing on here. Somewhere you do not see R. For me, like a back and forth. Right here, I do not see R. Those are blind spot. Do you have that moment? Kind of back and forth? Yeah? It's okay. Let's try. Right there. Yeah. So if you're focusing only like R, you do not see the. Yeah. Yes.
Still like there, but
yeah.
It appears and disappears.
That's right. So if you do maybe one more time, cover your right eye and focusing on only R. For me, okay, only focusing. Oh, right there. This is my like a blind spot. Yeah. So.
Same for both of them.
That moment. But if you kind of move a little bit, you can see L quickly, right? Yeah. So those are blind spot. That means that spot, the blind spot, we do not have any photoreceptor, which is rods or cones. Both are not there, blind spot. So that's why we do not see and we do not recognize any letters right there. But when you're looking at our eyes is not kind of putting one spot. So let's do here, maybe put your index fingers front and try to kind of hide your left eyes and see the image of your index finger. Okay, this time you just kind of cover different eye. And looking at the index finger, you do see like a little different image. It's not exactly same spot. Because we do have two eyes, and it's not, we have some distance between left eye and right eye. So even though you are looking at the same thing, hiding only one eye and the other, those image of your right index finger is different, right? That's why, since we are a little different, kind of looking always, you're kind of looking at a different angle, right? When you're kind of looking at this. So when you try to hide with one eye and focusing on one eye, still we do see and recognize R, but the other one is gone. Those are blind spots. So this is interesting way we can check the blind spot. It's kind of interesting, yeah. So let's go. Depth perception. I mean, we do have two eyes. I know some of the people, they have only one eye, yeah. But even though you have only one eye, we can recognize those in a depth cube, which is relative size, linear perspective, surface texture, and shading. But since we have two eyes, we can do binocular depth. We have two eyes and retinal disparity. So I will explain here too. So this is really famous Monet's masterpiece. If you're looking at this whole picture, the front, we do see a little tree, right? Kind of trees right there. And if you're looking at the further, what do you see? The back side.
Look like some buildings with orange roofs.
Yeah, yeah. So can you recognize those trees are more front? And those buildings are more further. Yeah, even though we have only one eye, we can see the difference. So here, the first one is a linear perspective. When you drive, even though the road is exactly parallel, but you feel like we are kind of going to one spot, like one kind of tiny right there. Have you ever noticed maybe when you go to Colorado and maybe certain other places, even though the road itself is parallel, right? But you feel like the vision looks like that left, yeah? Those are linear perspective. And if you're looking at this, I guess this is tulip. I want to say this is tulip. Do you feel like it's a tulip kind of, yeah, the flower?
The flower?
Yeah,
Tulip?
tulip or, it's not rose at least.
It's definitely not a rose, definitely
Yeah.
not a sunflower.
Yeah, so.
Probably some sort of tulip.
Okay. So when you're looking at this tulip, like a front one it looks bigger than the further one, right? Yeah. So further, we do have like a tulip the back then, but when you kind of compare the first, like a front one versus the further one, you do see this one is more bigger, relative size-wise, and the further one, it looks smaller, right? And looking at this is like, the number C can be Colorado. Yeah. If you're looking at the beautiful those scenery, and we do see two mountains, right? The first mountain and the second mountain is behind. If you're looking at that, the second mountain, like behind one, looks hazier, right? Compared to the first one. So we do see the difference. And sometimes those are perspective, even though you have only one eye. But since we have two eyes, we can recognize difference of the depth. So depth perception will happen because we have two eyes, and also it's not exactly same spot. We have a little distance between left and right eyes. So let's do one more time. So index fingers front. Do not move your index finger. So first, let's hide your left eye, and try to looking at your index finger. So kind of notice where your index finger is located. And then this time, cover your right eyes and looking at the index finger. Do you see the difference? The image is different, the index finger. Here versus here. For me, it's really obvious because, when I kind of put the index finger and try to looking at my left eyes, my index finger, the image is right here. But if I change it, my index finger image is right here. Yeah. Daniel, if you want to try, you can come here, but I know you do not.
Comparing it to the middle of your podium.
Uh-huh.
It'd be centered on my left, and then whenever I'd switch to my right, it'd be moved.
Yes, yes. Those are, we do have two eyes. So binocular cues, we can kind of sense those depth. Amazing, right? We are talking about anatomy of our eyes. So those are color vision is hue, the color of light. So this is like a fun activity. Why, how, and we can understand those all different kind of colors. So here we do, there are lots of theories done about color vision, interesting about the color. So when you are in elementary school, what is basic color? When you learn maybe some arts and crayons and color pencils, do you remember what's the basic color of, what's the three basic colors?
Red, blue, yellow.
Yes, yes, yes. Yeah, red, blue, yellow. Yeah, that's the color, basic color when you kind of draw, like a drawing, right? And the light and try to kind of receive and, interpret those, basic color. There are trichromatic theories. So tri means three. So three basic color, red, blue, not yellow, green. They believe it's one of the theory. We do see red, blue, green. It's kind of all mixed together and then making all different kind of rainbow color and even like ultraviolet and other colors too. So that's the trichromatic theory. Cons, do you still remember cons are color vision relating with that, specialized to sense red, blue, and green. And another theory is opponent process theory. Yeah, I do agree. Red, green, blue, yeah, it's good. But when red is, activating, green is inhibited. And when blue is activating, yellow is inhibited. So there's a good example. We will kind of experiment together. So here, opponent theory say image-wise, opponent process theory, there are four primary colors, red, green, blue, and yellow. Once one color is activating, the other color is more like showing after image, kind of inhibited. So next one, you're gonna look at the front, the center, there's a one white dot. Yeah, so next slide. One white dot, focusing on those for 30 seconds. I'm gonna, let you kind of see. So are you ready? 30 seconds, yeah? Okay, I'll be ready for my watch too. Okay. Focusing on the white dot in the middle for 30 seconds. Okay, keep watching. What do you see here?
Red, white, and blue.
Okay. Can you recognize what is those?
What do you mean?
Is it flag? Yeah. Do you see like a flag?
It was the American flag.
American
with the
flag.
dropper.
Yes, yes. Isn't it like interesting because those are after image based on their theory.
I still see it right on you.
Okay.
I'm looking at you. The U.S. flag.
Right there. Okay, okay, good. So that's maybe their theory. Maybe it makes sense. Do you feel like it kind of makes sense? Yeah, those four color, maybe activating and inhibiting, and after image we can kind of recognize. Yeah. So do you see still?
I still see it.
Okay. Interesting. Yes, very good. Okay, so let's go this one. What do you see here?
Two people looking at each other.
Okay, very good, very good. So I do see two. Is there any other things you do see maybe? If you're focusing on that object itself.
I mean, like I said, I see two pairs of people.
Okay, okay.
Let's see. I see maybe two types of cups.
Okay, very good, very good. So those are figure and ground organization. When you're focusing on the figure, the object, it looks like little cups, two cups together. And when you're focusing on the ground, like a surrounding area, more environment, you do see like two people kind of looking at each other. Yeah, so that's really amazing when we notice certain object. Let's see here. What do you see here?
A soccer.
Yes. if somebody asks me, what is this, Sarah? Yeah, soccer ball. But honestly, it's not soccer ball. It's not connected, right? But as a human being, whenever we do see this object, we just kind of assume as all connected. Oh, that's soccer ball.
Your brain tends to fill in the blanks.
Yeah. So those are Gestalt theory. They believe whenever you recognize maybe some proximity kind of right next to you, when you are in junior high and high school, maybe elementary school, have you involved any sports activities like basketball, soccer ball, and football? What kind of sports did you play?
Football, track, weightlifting.
Okay. Okay, so let's just say basketball. So when you are in basketball team, you are wearing some judge, right? Like basketball judge, and you recognize the same team because that's a uniform, right? So imagine you try to dribble and try to pass to somebody else. If your team is wearing the same uniform, it's easy to recognize, right? You do not see their face much, but you just kind of see their, the uniform and then passing very quickly. So based on their theory, as a human being, we do see the whole thing. Even though it's not all connected, recognize this one as a soccer ball. And next one, it will show a little bit here. Oh, yeah. So those are more like a uniform is try to not to kind of be individual figure, but try to recognize that person as the same team and kind of easy to pass when you kind of play those games. So those are more like a Gestalt theory. Let's do other things. Look at this 4 different picture right here and tell me which one is most weird looking to you. If I say number 1, 2, 3, 4. So right side, number 1, upside down 2, and 3, and 4. So
Probably 3.
3?
And 4 are pretty close to each other, but 3 is probably the weirdest.
Yes. Thank you. Because most of us, we feel like the third picture is most weird. Yeah, not comfortable. Even it's not human face. You may feel like that way. Yeah, because on the line, we do have a special facial recognition ability in our brain. It's a temporal lobe, like near your ears, temporal lobe, fusiform. That's the special, like recognition of your facial, yeah, and also letter too, yeah, all the human beings letter too. So it's Margaret Thatcher, yeah, Prime English minister. She looks really pretty for me, very beautiful woman right there. It's like just like a right size, yeah. And this is upside down. It's okay, it looks okay. I can recognize it's upside down. But when you're looking at the third one, your eye, nose, and mouth, it's inverted, like opposite. And something like it's not right. It's not a human being's face. It doesn't make sense. Yeah. So number 3, we recognize that one as not a human face because we do have those, recognition place in our brain. So remember, we do have a special modular perception underlined. Special modular perception. We have a special module to perceive human face and letter. Maybe that's why whenever we do see certain human, man, maybe female or male, oh, he's really handsome. Maybe she is really pretty. But most of people kind of agree with that because we do have a special perception, modular perception, to recognize human being's face. Maybe we do have a pretty woman versus not, starting from very early age. There is an experiment. Looking at 2 different pictures, most people kind of agree as a beautiful woman versus not, and even like an infant, like a 6-month-old baby, they will look longer for the pretty woman than not pretty woman. But the good thing is they did an experiment with one person. So one person wearing attractive mask versus one person wearing not attractive mask. And then they did those experiments, and even infant, they notice, at least recognize looking longer for the more attractive woman. People we kind of agree as a attractive woman. But I guess maybe portionally, maybe the attractive woman is more like the right side, not the other side. because we recognize that as more like an appropriate portion of the human face. Those are modular perception, and we do have a special facial recognition module in our brain. Interesting, right? Interesting. Okay, here, if you're looking at the A, there's like a two line right here, left and right. Which one looks longer to you?
The right.
Yeah, obviously, I've been kind of looking at, oh, yeah, the middle line, it looks much, the right side is much longer, right? But when you measure those, actually, the middle part is same length. Those are different arrow, but middle part is exactly same length. So we do have an illusion, like a visual illusion. So we will talk about those a little bit here. I know maybe you do not like snakes much, but do you feel like your snakes is moving, kind of rotating? Yeah, let's go. So we do have a special circuit, which is like constantly our eyes are moving. That's why even though it's not moving snake, but we can recognize that as a moving snake. How about this one? What do you see here?
A woman looking to the right.
Okay, do you see other woman? There are two women possibly.
Yeah, and then there's an old woman.
Okay. So the contextual, how you focusing on those, the young lady can be looking at that, yeah, front, yeah, and the young lady has some necklace. Maybe you can kind of looking at in that way. Versus old woman has a very, like very sharp chin, and maybe the nose is right there. And I realized some of the students, they cannot notice like old woman. They see only young woman, and also some of them, they see only older woman. Interesting, but we do have those, try to figure it out based on our perceptual set. So that was interesting. Yeah, let's go. Keep going. Hearing. Daniel, do you like to listen to music? Okay. Have you played any instrument, like guitar?
I don't currently, but I have played piano.
Piano, yeah, okay, good. Yeah, I used to learn piano when I was in elementary school, so I learned, how to play a little bit. So hearing, it's relating with our sound waves. So we will talk about anatomy of ear, like a hearing, like inside of hearing, right? So here, everybody, Daniel, can you touch your ears right here? Yeah, those are your ear. Underline, outer ear, those are pinna or maybe pinna. Those are pinna and pinna, outer side of ear. So imagine you are playing guitar. Maybe piano. We are playing piano or guitar. And ding, 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 the sound, like a sound wave is going through the pinna. Yeah, those are outer side of your ear. And then hit the tympanic membrane right here. Those are eardrum. It's very thin layer, so it can be break so easily. Yeah. So one of my friends, she has 4 sons, and one of her son poked her, like a little kind of toy, and then her eardrum was broken. But I remember it will heal. It will heal normally. It will take time, but it will heal. That means it's really thin layer, tympanic membrane. But when you kind of play the guitar, ding, 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 that sound go through tympanic, kind of hit the tympanic membrane and go through those ossicles. So when you're kind of looking at there are tiniest bone in your body, 3 bones. Those are ossicles. So kind of hitting all the ossicles. And here, if you're looking at here, that organ, what does it look like? Those whole thing.
Snail.
Yes. It looks like a snail. So those are cochlear. Inside of cochlear, there's a hair cell. Hair cell is there, and they recognize all the sound. Yeah. So here, ding, 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 the sound waves going through the pinna and hit the tympanic membrane or the eardrum, and then going through those tiny bones in your body, and then going through those cochlea and sending those signals to your brain. So let's cut your cochlea and try to see inside. But it looks like a snail, those are a semicircular canal because it's not fully circle but half circle, like a semicircular canal. So Daniel, when you are young, have you ever done kind of moving your body, going around and around and around? Yeah. So until you feel really dizzy. So you stop your body, but can you feel you feel like you're still kind of dizzy and going around and around and around? Yes, yes. That's the reason of a semicircular those canal, because it's filled with fluid, like a water kind of fluid, right? So even though your body is stopped, still you feel like try to make a balance and then going around and around for a while, because there's like a fluid in it. So here, semicircular canal is right there, and right here, vestibule. It's relating with your balance. So when you're kind of going through, like maybe having fun, going around and around and around, feeling a little dizzy, and then you stop, but you feel like your world is still kind of moving around, right, for a while, and try to make a good balance. It's all relating with those right there. Those are part of a balancing part. Do you still remember the cerebellum? Yeah, it's kind of balancing, kind of moving your behavior, your body. But in your ear side, there's like a balancing part too. Those are vestibule right here, inside of your ear. So those are cochlear. Let's cut cochlear. So try to see the hair cell here. Those are more like a detailed information. When you cut those cochlea, you will see organ of Cori, and it does have a lot of hair cell. But once again, I know you are listening my lecture as a concurrent students. Do not listen to music too loudly, and if you are involving in percussion, try to wear earplug when you practice your drum, because once you lose those hair cell, it will not come back. You will lose it, and you lost it, and maybe you may have some hearing problem here and there if you can expose to too much loud noise. Always try to protect yourself. Okay, so those hair cell will be inside of your cochlea. Okay, so here, some of you, maybe you may know somebody else, maybe having some hearing problem, starting from the early age. And have you ever heard about like a cochlear implant? Cochlear implant. So you heard of it? Yeah?
Hearing aid.
Yes, hearing aid. So imagine maybe a child, maybe baby was born and cannot hear. There are so many different reasons, right? Maybe ear shape can be a little different. Maybe there's no ear. Maybe inside everything looks okay, but cochlear doesn't work. But cochlear actually does have a hearing receptor, hearing cell. So in that sense, we do have a sign language. Yeah, sign more please. That's only my sign language. More please. Yeah, that's the sign language. So maybe we can communicate the sign language. But high technology, you may do cochlear implant. So usually backside of your ear, right here behind your ear, and inside and outside you have those devices like a microphone, amplify all the sound, sending those signal using those electrode like an array, and sending those sound and putting into your cochlear, because your cochlear doesn't work at all, right? Because the hearing cell is right there. So here, and then connecting to the auditory nerve, so help you to hear the all different kind of sound. One of my friends, he had those cochlear implant starting from very early age. He told me he can pretty much hear every sound, but the sound is different than we do here. It's a little different, but still he can recognize a human being sounds as a different, like a different person have a different voice and different tone, but it's not exactly the same what do we hear. But it's really helpful for them, and they need to change those implants, couple of years, sometimes depending on, but they need to check, every year at least, it's working or not, and how much they can hear, maybe less, maybe more. So that's the important device for the people who suffer hearing problem. Okay, let's talk about smell. Do you have any good memory relating with the smell? like maybe goulash, your favorite food, and whenever you feel hungry and go back home, maybe your mom making some goulash for you. So anything like relating with a good smell, like a cookie, maybe chocolate chip cookie, maybe your grandma make a cookie all the time whenever you visit her house. Yeah. So anything like relating with the smell, like maybe it can be good memory and bad memory. Do you have any of those memory relating with the smell, Daniel?
I mean, yes and no.
Yes and no? Okay,
So
okay.
it's like I can have a smell that reminds me of something, but I don't remember what it was.
Okay, good. So usually people kind of kind of sensation. The smell is part of the sensation, right? I was using the sensory receptor. So when you kind of remember certain smell, memory comes with you. Yeah, it can be good memory and sad memory and bad memory. Usually smell, maybe certain perfume. Let's say this perfume. Maybe ex-girlfriend used to wear certain kind of perfume. So whenever I kind of smell that perfume, remind her. Yeah, it can be. So it's a memory relating with, smell is lots of memory relating with those. Yeah. So smell-wise, we do have 350 to 450 receptor cells. That means that's why we have so many different kind of smell. We can recognize the differences, right? Underline. So when we smell certain maybe perfume and maybe food and flowers, it's through the cilia, little kind of hair cell, and directly go to olfactory bulb and olfactory cortex. So I will show that one. How many noses do we have? We have one nose. How many nostrils do you have? Two nostrils, right? So when you kind of imagine, when you smell this perfume, through those two nostrils, there are hairs. Yeah, those are, cilia, those hair cells is right there. So through those hair cells, kind of smell those perfume, and unlike other sensation, you do see, you do kind of touch, you do taste. First place is thalamus. Do you remember kind of going through your brain and hit the thalamus? So thalamus is sensory in a place. But thalamus is right there. The purple area is thalamus, right? So when you hear, when you see, every kind of those sensation first go through the thalamus, those purplish area, and then sending signal to the upper part of your body, but except smell. Why? Smell, the nose is right above, there's an olfactory bulb. So when you smell, those like little hair, cilia, kind of through the cilia, we recognize those smell, and sending those signal directly to the right above those hair cell, which is olfactory bulb. So you do not send those signal to the thalamus. So smell is the only one, you do not send those signal to the thalamus, but other sensation you see, you do hear through the thalamus first, and then sending signal to the upper body. But smell through cilia, and then sending because it's connected. It's connected. Cilia is connected with the olfactory bulb. So you recognize those smell and sending directly to your brain. Yeah, so you don't need to go through thalamus. But for your exam, remember when you smell certain things through the cilia, and because it's connected, olfactory bulb and olfactory cortex, instead of go to thalamus, right? That's the way you do smell. Okay. Oh, maybe I need to ask you. So let's go to the taste. How many tastes can you feel? Can you name any taste? Yeah?
Salty.
Salty?
Sweet.
Sweet?
Sour.
Sour?
Bitter.
Bitter?
I don't know.
Good, very good.
Texture is a lot involved with me.
Yes.
I like most flavors, but texture is what throws me off.
Oh, I see. Like maybe some potatoes and kind of mushed
Sweet potato, I
one.
don't like sweet potatoes.
You like it because it's too
Like
mushed?
I do, but I don't like a sweet potato by itself. I don't like the taste of it.
The taste
I would
is
do
sweeter.
Sweet potato fry or something.
Yeah, okay, I understand. Yeah, because if you compare the potato and sweet potato is kind of more mushed and kind of more boiled one, right? But the French fries like a sweet potato is really good, like a sweeter than potato. So I totally get it. So here, most of us we recognize sweet, sour, salty, and bitter. The last one is umami. What is umami taste? Umami is like a beef broth. When you put like a beef and then maybe boil for 1 hour and then taste it, it's like a brothy and like a beef broth and chicken broth, more like a MSG, like a little ramen, Yeah, yeah, kind of more like a brothy and mushroom taste like, yeah. So it's a good if you like a meat and meat kind of in a taste, like a more kind of rich taste, brothy. Those are umami taste. So if you're looking at your tongue, maybe like this, on your tongue, there's got white little dots. That's not taste bud, underline taste bud. So taste bud is, we can recognize all different kind of sweet, sour, salty, bitter, and umami. Yeah, those are under those white thing. So on your tongue, the white part, those are palate. So under those palate, you will see taste bud under that. So all different kind of 5 basic taste you do feel. So
I feel like your roof of your mouth has taste buds too.
yeah, but yeah, I guess maybe different in the places a little bit, but basic like a taste bud, it's under the tongue. Yeah.
I just feel like whenever I'm eating something kind of sweet and I like push it against my roof of my mouth,
Okay.
I taste it more.
Okay.
But
Yeah, so those taste bud is located under your tongue, and you can clearly taste those four to five. Yeah, as a human being, we have 5 different tastes. Umami. So umami is more like here, savory protein, like beef, chicken, mushroom, and soy. Like a special, like a MSG kind of in type of like a taste. It's good taste, yeah. So people really like umami taste. Those are umami and brothy. Those one of the taste. Okay, so remember, sweet, sour, salty, bitter, umami. That's we, as a human being, we kind of taste those. Okay, we are almost close, but maybe we may not, honestly, we may not finish this chapter. We have maybe a couple of 1 or 2 more slides. So don't worry about the exam tomorrow. We will finish this chapter next Tuesday, and Wednesday you can take exam. But Tuesday, for sure, I will go to the next chapter, chapter 4. But since I'm going to finish this chapter instead of today, it will be next Tuesday. Your exam will be next Wednesday. So during the weekend, you can study more, right? Okay, so here, somatosenses. Can you describe to me what's happening to that man?
getting hit with a snowball in the face.
Okay. So how does maybe he would feel? Like, what's the kind of feeling?
Cold.
Cold, yeah, very cold,
A
yeah.
little bit wet because it's melting as it's hitting them.
Yes, yes. And what else?
Slight sting.
Yes, it's kind of pain, huh? It's very hard, kind of in a snowball, right? Okay. Okay, so have you ever done any like snowball fighting, with making snowman? I know here in Oklahoma, we do not have not much snow, but at least like 1 or 2 big snow in the winter time. So school closed. That's my favorite part, right? But if you're looking at this man, maybe fighting, like playing snowball game, yeah, a snowball fight, and then by hit by one big gigantic snowball, ooh, it's painful. It's wet and cold, yeah, and a little pressure. Those are underlying somatosenses. Somatosenses, your body, skin, you can recognize. Coldness, yeah, pressure, and pain. Those are somatosenses, yeah. Have you ever had those, maybe those snowball fights when you are young? Yeah, yeah. So making some snow angels and yeah. If it's a snowy day, what do you usually do? I mean,
Stay inside.
staying inside.
I absolutely hate the cold. I spent about 7 years in Louisiana, and
Uh-huh.
I didn't like the cold after I left Louisiana.
So Louisiana is much colder.
It's much warmer. It
It's
doesn't
warmer?
have cold weather. It snowed one time in the 7 years I lived there.
I see.
And it was record.
Okay.
You know, it never snowed in Louisiana.
Yeah. So we will talk more about this topic next Tuesday.